Talk about how to integrate when you have an even power. So last time I showed you how to do it for odd power, but if this is even, then if you take out one of the sine functions, you end up with an odd power, and the odd powers cannot be converted into cosines. So you have to use a completely different strategy for integrating this, and even the antiderivative looks completely different than the odd power case. Okay? So you just have to know that those two integrals, they look similar, but the approach is totally different. Okay, so what we do is we first take sine squared of x equal to this identity that we talked about, right? It's 1 minus cosine of 2x over 2. And we use that to think of the fourth power as square of the square. Replace sine squared by this thing, 1 minus cosine 2x over 2 squared dx. And then you have to square the top and also the bottom. The bottom is 4, right? So you end up with the 1/4 outside. And you have to expand 1 minus cosine 2x. That's right. Okay, for this we will use a minus b squared is what? A squared minus 2ab plus b squared. Okay? So there's this identity, right? So that you end up with 1/4 of the integral of 1 squared minus 2 times 1 times cosine 2x plus cosine squared 2x. Okay. And let's simplify before we do any more calculation. 1 minus 2 cosine 2x plus cosine squared 2x dx. And this time we have to use the other formula for the sine squared x. So it's not the sine squared, but the cosine squared of x. What's the formula that corresponds to this one? What goes on the top?
1 minus sine.
No,
One
it's
plus
1 plus cosine 2x. So one has a minus, the other has a plus. Okay. Okay, so we're going to use that. And we can break up all these integrals into 3. 1 dx plus 1/4 of negative 2 cosine 2x. 1/4 of cosine squared 2x, but that can be replaced by 1 plus cosine 4x over 2. And that's because instead of x here, we have 2x. Therefore, when you do a double of the 2x, it's going to end up being 4x. That's how you get the 4x. Now, what's the antiderivative of 1?
0.
No, that's the derivative.
Oh, x.
X, right. Okay. Well, I can pull a minus sign out. So let's just do the integral of this much. Now, for that one, we're going to use the following formula. Integral of f of ax plus b dx equals to 1 over a capital F AX plus B plus C. So we talked about that shortcut last time, and it looks complicated, but all it's saying is the following. If F has an antiderivative of capital F, and you have something complicated like AX plus B in there, then the only difference is that this A causes 1 over A to appear. That's all it is. Okay? That's what this formula is saying. So the only thing that's really important is this one. Just have to remember that. Okay? This entire formula is just about this one. So what does it mean for here? Well, let's just put the 2 here. So negative 2 I pulled out. So we're only integrating cosine 2x. So what's the antiderivative of cosine? Is it positive sign or negative sign? It's the positive sign. Okay, it's confusing. It's positive sign. So you put sine of 2x, but then what would you put in here? What does the formula suggest?
1/2.
You put 1/2. This 2 causes 1/2 to appear. Okay, so these two cancel. Okay, well, this one is again, that's 1/8. 1/4 times 1/2 will be 1/8. And you still have to integrate 1 plus cosine 4x dx. Let's see, that's 1/4 of x minus 1/4 of sine 2x. 1 integrates to x, so there will be another 1/8 of x. And then let's think about this one. What's the antiderivative of cosine 4x? What would you get? First, antiderivative of cosine is?
Sine.
Sine. It's positive sine. And you have 4x. What do you put in front?
4.
1/4. That's what this formula is saying. This reciprocal comes in front. Okay, now you simplify, and that's the final answer. It's 1/4 plus 1/8 is 3/8 minus 1/4 sine 2x plus 1 over 32 sine 4x plus c. Yes?
So we can just assume that the b is 0, right?
Oh, yeah, that's a good question. So when we say we are applying this formula for sine 2, cosine 2x, for example, we have a as 2 and b as 0. So b didn't appear, but what this is saying is that even if there was a b, it doesn't do anything to the antiderivative. Only this a would come out as a 1 over a.
Okay. So if it was 2x plus 1, it would
It will still be 1/2 sine 2x plus 1.
Okay.